Okay, so yesterday we had done the plugging in portion, and we figured out that for the first interval from negative infinity to negative 2, both pieces turned up negative. For the middle portion, we ended up with a positive and a negative, and for the right-hand portion, we ended up positive and positive. So the next thing we have to do, I think we did this yesterday, but we went back and we had to make both pieces negative. So I put a negative in front of the first piece and a negative in front of the second piece and distributed them. So it would be negative x minus 2 minus 2x plus 3, and then you simplify that. So that's where this came from, negative x minus 2 minus 2x plus 3. I simplified that. Yesterday when I did it, I simplified it wrong. Negative 3x, it should come out to be negative 3x plus 1. So, and we know that that's for the interval where x is less than or equal to negative 2, or from negative 2 to negative infinity. Then on this middle piece, I have the positive that I'm going to distribute to x and to 2. So you end up with x plus 2 minus 2x plus 3. And then simplify that. So I've got x plus 2 minus 2x plus 3. When I simplify that, I get negative x plus 5. That's on the middle interval from negative 2 to 3 halves. And then the last one, they're both positive. So you end up with x plus 2x minus 3. Combine like terms, and I get 3x minus 1. And that's for the interval of x is greater than or equal to 3 halves. So then I'm going to graph that. So I started by graphing this linear piece because the 5 is really easy to see and the slope is negative 1. So I went up to 5, went over 1, down 1, over 1, down 1, up 1, over 1. And that is only on the interval of negative 2 to 1.5 or 3 halves. So I stopped at negative 2 and I stopped at 1.5. Now my next one, I'm going to go back and do this one. It should start right here at this place. If I were graphing the whole thing, I would start with my slope-intercept of 1 and draw a dot at 1. And the slope is negative, so I can either go down 3, right 1, or you can go up 3, left 1. It doesn't matter. So from there I go up 3, left 1, up 3, left 1. And it does end up right there at that dot. Up 3, left 1, up 3, left 1. So this piece looks like that. And then the last piece is this one. Using slope-intercept form, it's at negative 1. My slope is 3, so up 3 over 1, up 3 over 1, up 3 over 1. So that looks like this. And it is only on the interval where x is greater than 3 halves, so that's why it starts with 3. So it looks like that. I didn't use the straight edge, so it's not perfect, but it's a pretty good estimate. My domain is negative infinity to positive infinity. Range looks like 3.5. Okay, so let's do number 2. I know you did it for homework, so let's go over it together. You are just going to go step by step through the process, just like we did for all the others. So the first step is to take what's in the absolute value and set it equal to 0. In this case, that is just the x plus 4. It doesn't matter what's in front of the absolute value. It doesn't matter what it's equal to. You take just what's inside the absolute value and set it equal to 4. I subtract and I get x equals negative 4. Then you set up a number line. That negative 4 goes on the number line just to divide your intervals. I have 2 intervals, from negative infinity to negative 4, so this arrowhead to negative 4, and from negative 4 to infinity. Now it tells us, my instruction, step 2, says take the equation, put it on both intervals, but get rid of the absolute value signs, instead make them parentheses. It's going to be x plus 4 plus 6 in both places. Is everybody okay so far? Alright, now I have to plug in a value for each interval. So I'm going to talk about this left-hand side first. That would be from negative infinity to negative 4. You can choose whatever number you want. It doesn't matter. I could choose working that out, negative 5 plus 4 is negative 1. Negative 2 times negative 1 plus 6. It does not matter what the number comes out to be. I mean, you can go ahead and figure it out if you want to, but it really doesn't matter. All that matters is if it's positive or negative. And in this case, it is positive. Because that is 2 plus 6, which is 8. Okay, so now, I go up and I look what is on my interval from negative infinity to negative 4, and right now, this equation is negative because of this negative 2. I have to make it positive. That is what this information just told me. So I'm going to change that negative 2 to a positive 2. Now I'm going to try the other interval. From negative 4 to infinity. You can choose any number that lies on this side of the number line. An easy one to choose is 0. So I'm going to plug in 0. In this case, it comes out to be negative. Because negative 2 times 4 is negative 8, plus 6 is negative 2. That is a negative number, which means this piece has to be negative. It already is, because it has a negative 2 in front of it. So I can leave that right-hand piece as negative. So now what I have to do is go back and distribute and combine like terms if I need to. So on this top piece, this is a positive 2 that I'm going to distribute. That would give me 2x plus 8 plus 6, which when you combine your terms is 2x plus 14. That's one piece. That's the piece from negative infinity to negative 4. I'll write it all out in just a second in this one space. And then for this piece, I have a negative 2 that I'm distributing. So I have negative 2x minus 8 plus 6. So I get negative 2x minus 2. That's for this other interval. So I have two pieces. 2x plus 14, and that's on the interval where x is less than or equal to negative 4. And then negative 2x minus 2, and that is on the interval where x is greater than or equal to negative 4. So now we're going to graph this and see what it looks like. So I'm going to start with this one so that I can at least get my endpoints, because this one has a positive 14 and there's no 14 on my graph. It's not going to matter, you'll see in a second. But I'm going to start with this one, so I will go to negative 2. If I'm graphing this by slope intercept, I go to negative 2, and my slope says go down 2, right 1, or go up 2, left 1, up 2, left 1, 2, left 1. The only value I need is this piece is where x is greater than or equal to negative 4. Well, here's negative 4. I've just put a dot there. I have all these dots you can connect. And then I can graph the other side. It's got a positive slope of 2, so it's going to be going down 2 over 1, down 2, left 1, that would be positive. Domain is negative infinity to positive infinity. And your range is negative infinity to 6. Okay. All right? Yes, ma'am.
How do you do that?
Well, because like, do you understand the getting of the negative 4 and then setting up with the number line?
Yeah, I mean, no, I'm saying like, I understand all of it until you did the last 3.
Okay, if you could you should be able to do this piece by looking at what the number is, and then this piece of graph, that was this one that I found right here, it represented this piece, right? You get the negative infinity and negative 4 part. Okay, that's this. Well, the arrowhead points this way, so that's why I know this arrowhead points that way. Do you understand what I'm saying? No, it's not stupid. It isn't. And the reason I agree with you, it can be confusing because we're so used to, and I am so used to using interval notation, I prefer it. So sometimes writing it this way is confusing, but if you'll just look at the arrowheads, it'll help. Because this one is this arrowhead, so it points the arrowhead. Okay. And then I'll show you on the next one because we're going to have one that's in between. So, all right. So on this one, it looks a little bit more difficult, but it's really not. The only thing you have to consider is we now have the denominator. And what can never, ever, ever happen? Right, you can never divide by 0. The denominator can never go to 0. What number would cause that to happen here? 5. So we know x cannot be 5. We have to consider that. It has to be part of our consciousness while we do this, or we'll run into a little trouble. So the rest of it is going to be the same. So we're going to take the absolute value pieces and set them equal to 0. So x plus 1 equals 0 and x minus 3 equals 0. So x equals negative 1 and x equals 3. Now when I set up my number line, I have to include, I have to put the 5 on the number line as well because x can't be 5. So we have to consider that when we're making our separate pieces of our piecewise function. So I'm going to set it up with negative 1, 3, and 5. So that makes extra intervals for me. But the process is still the same. You're going to set up your function with parentheses instead of absolute value signs in each one of the intervals. Honestly, we really don't care about the denominator at this stage in the game, but I'm going to write it just because it's part of the function. I gave you lots of room for this one because you've got lots of intervals to do. So my first interval is from negative infinity to negative 1. So negative infinity to negative 1. I'm going to plug in any value there that I want to, so I'm just going to use negative 2 because that's easy. I do not really care what happens in the denominator right here, so I am not even going to mess with it. So that I can just leave it as x minus 5 because it really doesn't matter right now. All I'm trying to figure out is whether or not these pieces become positive or negative. My first piece is negative. My second piece comes out negative. Because negative 2 plus 1 will be negative 1. Negative 2 minus 3 is negative. So both of these pieces are supposed to be negative. So when I come up here, I have to make them both negative.
Wait, did you say you just did right up?
Yeah. Because it wasn't an absolute value piece anyway. So it is what it is. It can't be 5, I know that. So I'm not really concerned about it right now.
Okay.
Now I have to go from negative 1 to 3. Zero's between there, so I'm going to use 0 when I plug in. My first piece comes out positive. My second piece comes out negative. So I have to make sure that that's what they look like. My first piece is positive. My second piece has to be negative. Now I need to go from 3 to 5. So remember, the bottom can't be 5, so I can only go right up to 5. So I'm going to plug in 4. My first piece comes up positive. My second piece comes up positive. So these are positive and positive. And now I'm going to go from 5 to infinity. So I'll plug in 6. First piece comes up positive. Second piece comes up positive. Is everybody okay? so now we get to the distributive part of this. So I'm going to come up here and I'm going to distribute this negative for the first interval. So that's going to be negative x minus 1 minus x plus 3. Everybody okay? Combining like terms, that's negative 2x plus 2. Second interval, I'm distributing a positive the first time, so that's positive x plus positive 1 minus x plus 3, because that's negative negative. Combining like terms, what happens to your x's? It should cancel. And you end up with just 4. My next piece, I distribute the positives. And I get x plus 1 plus x minus 3. That's 2x minus 2. The last set is actually exactly the same. So we'll deal with that piece in just a minute. Alright, so when I rewrite my function, now I just have to write it with constraints. So this is h of x. My first piece that we did, this piece right here, the negative 2x plus 2, is going from negative infinity to negative 1. So if I look at my number line, the arrow's pointing this way. So that's the way my arrow needs to point. It's going to be negative 2x plus 2. And that's going to be where x is less than or equal to negative 1. My second piece, there's a constant piece. The answer is 4. And that's going to be, and that was this one right here. And it was just between the values of 1 and 3. So you put negative 1 and 3. X is between those things. And then remember the arrowhead's always when it's a between thing. And then these two are identical, so you only have to write it one time. I just have to consider that whole x can't be 5. So I'm going to write 2x minus 2, and then this is where x is greater than, this is from here, from right here over, and the arrowhead's pointing to the right. So this is where x is greater than or equal to 3, but x cannot be 5. So I'm going to write x cannot equal 5. That way we know it's x is greater than 3, every number but 5. And that's why we had to remember that this 5 was in there. Is everybody okay?